Hello, I am Dr. Shrutishrubha Bharali and I welcome you all to this video lecture on understanding classes and objects in Python, which is a part of the online course on open source software for academia. In this video lecture, we will delve deep into the foundational concepts of classes and objects in Python, which form the backbone of the object-oriented programming paradigm. The lecture video begins with an introduction to the principles of object-oriented programming and explains how Python, a versatile and powerful programming language, supports this approach through the use of classes and objects. In this video lecture, we will learn how to create classes and instantiate objects in Python. With the help of relatable and easy to follow examples, we will explain the process of defining classes, initializing attributes using constructors, and creating methods that define the behavior of objects. Moreover, the video will cover the different type of methods used within a class, including instance methods, class methods, and static methods. Each type will be explained with detailed examples to illustrate their unique purposes and how they are defined and called in Python. Beyond the basics of classes and objects, the lecture will also introduce the powerful concept of inheritance in Python. In this lecture video, you will learn how inheritance allows a class to acquire properties and behaviors from another class, promoting code reuse and reducing redundancy. The video will explore different types of inheritance that are supported in Python, namely single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance, and demonstrate how each type works with practical examples. By the end of this video, you will be equipped with the knowledge and confidence to write your own classes and objects, utilize various types of methods, and implement inheritance effectively in your programs. Object-oriented programming is a programming paradigm based on the concept of objects, which can contain data, also called attributes or properties, and code, which are also methods or functions that operate on the data. Let us now look at the principles of object-oriented programming. The first one is encapsulation. Encapsulation is binding data and methods that operate on the data into a single unit and restricting access to some of the object's components. This is done to protect the internal state of an object and only allow access through public methods. The next is abstraction. Abstraction is hiding complex implementation details and showing only the essential features of the object. This is done to reduce complexity and increase efficiency. The next one is inheritance. Inheritance is the mechanism where one class inherits the properties and behaviors of another class. This is done to promote code reuse and logical hierarchy. The next is polymorphism. Polymorphism is the ability of different classes to be treated as instances of the same class through a common interface, usually by overriding methods. This is done to perform a single action in different ways. We will explore inheritance in detail in this video lecture. But first, let's make sure we understand what classes and objects are. A class can be defined as a blueprint or template for creating objects. It defines a set of attributes and methods that each object will have. An object is an instance of a class. It is a real-world entity that contains data and methods that operate on the data. The general syntax of a class is shown in this slide. A class is defined using the keyword class followed by the class name. Optionally, the word object can be placed in parentheses after the class name, indicating that the class inherits from Python's base class. However, including object is not necessary, as all classes in Python implicitly inherit from it. A docstring written using triple single or triple double quotes is used to describe the purpose of the class. The class can contain attributes which are variables used to store data. The init method is a special initializer method used to assign values to these attributes. Method 1 and method 2 are additional methods that can be defined to operate on the data stored in the attributes. A method is basically a function that is written inside a class. There are two ways to call a method. The first one is class name dot method name, and the second one is instance name dot method name. Let us look at an example of a class. By convention, class names in Python begin with a capital letter, which is why the employee class here starts with an uppercase E. Since Python does not require explicit variable declarations, we define variables inside a special method called init, which is used to initialize them. This method is surrounded by double underscores on both sides, indicating that it is a built-in or special method. It is not meant to be called directly by the user. The keyword self refers to the current instance of the class. To access instance variables, we use the dot operator with the self, such as self.name, self.age, and self.salary. The display data method takes self as a parameter and uses it to access and display the values of the instance variables. To create an instance or object, the syntax would be instance name is equal to class name. So, to create an instance of the employee class, we will write E1 equal to employee. Here, E1 is the instance name. So, any variables or methods in the instance can be referred by E1 using the dot operator. For example, E1 dot display data the program to define an employee class and create an object is shown in this slide. We can see here that the display data method displays the name, age, and salary for the employee object E1. Self is a default variable that refers to the current instance of the class and holds its memory address. When an object of the class is created, the object's reference is automatically passed to self within class methods. This allows access to the instance attributes and methods from within the class. An instance of the employee class can be created using the command E1 equal to employee. In this case, E1 holds the memory address of the newly created object. This address is automatically passed to the self variable. We can use self in two ways. As the first parameter in the constructor method, for example, def init self, or as the first parameter in instant methods, such as def display data within parentheses self. Here, the display data is an instance method and it operates on the instance variables of the object. A constructor in Python is a special method used to initiate objects when a class is instantiated. It is automatically called when a new object of the class is created. The constructor method is defined using the special method init. It runs automatically when a new object is created. It is mainly used to initialize instance variables. The self variable is always the first parameter of the constructor and holds the memory address of the current instance. We can see this in this example. Here, the constructor has only one parameter, which is self, and it can be called using the line E1 equal to employee. The empty parenthesis here indicates that no arguments are being passed to the constructor. However, constructors can also accept arguments. Here we have modified the code for the constructor to include parameters. Here, the parameters n, a and s have default values RIA, 30 and 10,000. So, if we create an instance without passing any values like E1 equal to employee, then the default values will be assigned to the instance variables name, age and salary. But if we create an instance like E2 equal to employee with three actual arguments, Priya, 25 and 40,000, then these values are assigned to the parameters n, a and s and then stored in the instance variables name, age and salary. In the program, we can see that the constructor with and without arguments have been used. Now let us look at the type of variables in a class. There are two types of variables and they are instance variables and class variables, which are also called as static variables. Instance variables are unique to each object created from a class. This means that every time a new object is created, a separate copy of the instance variable is created for that object. Changing the value of an instance variable in one object does not affect the value in another object. Let us look at the program to understand instance variables. In this example, name is an instance variable in the class person. Even though both P1 and P2 are objects of the same class person, they have their own name values. This can be seen in the output that changing P1.name does not affect P2.name. Class variables are variables whose single copy is available to all the instances of the class. Changing the value of a class variable in an instance will change its value in all the copies in all other instances. Let us look at a program to understand class variables. In this program, company name is defined as a class variable, which means it is shared by all instances of the employee class. Now, to modify the value of a class variable, Python provides a special built-in decorator called class method. A class method is a method that is bound to the class rather than the instance. It takes the class itself as the first argument, which is conventionally named as CLS. This allows the method to access or modify class level variables. In this example, the method change company is declared as a class method using the class method decorator. It receives CLS as its first parameter, giving it access to the class and its variables. When we call the method using employee.changeCompany and pass ABC Robotics Company, it updates the value of the class variable company name to ABC Robotics Company. Since company name is shared by all instances, this change is reflected in every object created from the employee class, including the previously created objects C1 and C2. Thus, both instances now refer to the updated company name, demonstrating how a class method can be used to modify a class variable for all instances simultaneously. There are three types of methods. They are instance methods, class methods, and static methods. Instance methods are the functions defined inside a class that operate on the instance variable of that class. These methods are specifically designed to work with the data that is unique to each object or instance of the class. Since instance variables are tied to a specific object, instance method must be called through that object or instance. So, we can use the syntax instance name dot method. The first parameter of every instance method is self, which refers to the current instance calling the method. Through self, the method can access and modify the instance own variables. Let us look at a program to understand instance methods. In this program, name and salary are instance variables specific to each employee. Here, the display info method is an instance method that accesses and prints the values of these variables. We call the method using the instance name, such as e1.displayInfo and e2.displayInfo. The self parameter inside displayInfo refers to the instance, either e1 or e2, that calls the method. Class methods are methods that work with class variables or static variables which are shared across all instances of a class. Unlike instance methods that act on individual objects, class methods operate on the class as a whole. To define a class method in Python, we use the built-in decorator at class method, placed just above the method definition. The first parameter of a class method is conventionally named CLS, which stands for the class itself. This allows the method to access or modify class level data. Class methods are typically called using the class name followed by the method name, like classname.method. Let us look at a program to understand class methods. This program defines a class employee with a class variable company name that stores the name of the company. A class method display company is defined using the addClass method decorator, which allows access to the class variable through the class parameter. The method prints the value of company name. The class method is then called using the class name employee.displayCompany. This demonstrates how class methods can access and display class level data without needing to create an object. Static methods are used when a specific functionality or processing is logically connected to a class but does not require access to the class itself or any of its instances. These methods are helpful when the task to be performed is related to the class role or responsibility but does not depend on any class variables or instance variables. Static methods are defined using the addStatic method decorator. Unlike instance methods or class methods, static methods do not take self or class as their first parameter. This means they do not have access to the current instance, which is self, or the class, and cannot access or modify instance level or class level data directly. Static methods are typically used for utility tasks, helper functions, or common operations that support the class logic but function independently of class data. Let us look at an example to understand static methods. This program defines a class employee with a class variable company name. It includes a static method showMessage using the addStatic method decorator. The method simply displays a welcome message. It is called using the class name employee.showMessage, showing how static methods work independently of a class or instance data. Inheritance is a fundamental concept of object-oriented programming that allows a class called a child or subclass or derived class to inherit attributes and methods from another class called a parent or superclass or base class. Inheritance promotes code reuse and helps to create a hierarchical relationship between classes as the child class inherits all the methods and properties of the parent class. Inheritance helps to model real-world relationships. For example, a car class might inherit from a vehicle class because car is a vehicle. Python supports different types of inheritance like single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. In this slide, we have the syntax and an example. In the syntax, we can see that first we have the parent class followed by the child class. In the example, we have a parent class named vehicle. The program has a constructor in it that initializes the brand attribute. It also has a method start that prints a message indicating the vehicle has started. The brand name is included in the output using f-string formatting. This code defines a class car that inherits from the vehicle class. This means car automatically gets all the properties and methods of vehicle, including the brand attribute. The car also defines its own method, drive, which prints a message showing that the car is driving. The message includes the brand name inherited from the parent class. Single inheritance is a type of inheritance where a child class inherits from only one parent class. This means the child class acquires all the attributes and methods of that single parent class, allowing code reuse and extension. Let us look at an example to understand single inheritance. This program demonstrates single inheritance in Python. The car class inherits from the vehicle class and reuses its constructor and method, while also defining its own method in the program. In the example, an object C of car class is created. Tata Motors is passed as the brand name. Because car inherits from vehicle, it uses the init method of vehicle. C.start calls the start method inherited from the vehicle class, which prints the vehicle starting message. C.drive calls the drive method of the car class, which prints the car is driving message. Multiple inheritance is a feature where a child class inherits from two or more parent classes. This allows the child class to access attributes and methods from all its parent classes. This type of inheritance helps in reusing code from multiple classes. The child class can combine features of all parent classes. Python uses method resolution order to decide the order in which methods are inherited. Let us look at an example to understand multiple inheritance. The program here demonstrates multiple inheritance in Python. It defines two parent classes, engine and wheels. The engine class has a constructor that sets the engine type and a method showEngine that displays it. The wheels class similarly has a constructor that sets the wheel type and a method showWheels that prints it. The car class inherits from both engine and wheels. In the car constructor, it calls the constructors of both parent classes using engine.init method and wheels.init method to initialize their attributes. It also defines an additional attribute airbags specific to the car class. The car info method in car displays the number of airbags. An object C of class car is created with the engine type diesel, wheel type alloy and 4 airbags. The C.show engine method and C.show wheels methods display the inherited information from the parent classes. Finally, C.carInfo method shows the car's safety feature demonstrating how the child class combines features from multiple parents. Multilevel inheritance is a type of inheritance in which a class inherits from a child class which itself is derived from another parent class. This forms a chain of inheritance across multiple levels, hence the name multilevel inheritance. In this type of inheritance, a child class inherits from a parent and another child class inherits from that child. This allows the lowest level class to access all attributes and methods from its entire inheritance chain. That is, the last class in the chain can use all the features of its ancestors. Multilevel inheritance supports code reuse across multiple levels. Python handles this inheritance chain using the method resolution order to determine which method to execute when there are multiple levels. Let us look at an example to understand multilevel inheritance. This program demonstrates multilevel inheritance in Python using 3 classes: vehicle, car, and sports car. The base class vehicle has a constructor in it that initializes the category of the vehicle and a method showCategory to display it. The car class inherits from vehicle, meaning it can access all the attributes and the methods of the vehicle class. In the car class constructor, super.init with category as parameter is used to call the parent class constructor to initialize the category. The car class also adds a new attribute, brand, and defines a method showBrand to display the car's brand. The sports car class inherits from the car class, which means it also indirectly inherits from vehicle, forming a multi-level inheritance chain. The sports car constructor calls super.init with category and brand as parameters to initialize attributes from both the vehicle and car classes. It adds a new attribute topSpeed and defines a method showSpeed to display the speed. An object SC of the sports car class is created with the values 4-wheeler, Ferrari and 320 as category, brand and topSpeed. The method sc.showCategory is called which accesses the method from the vehicle class and prints category 4-wheeler. The method sc.showBrand is called which accesses the method from the car class and prints brand Ferrari. The method sc.showSpeed is called which accesses the method from the sports car class and prints topSpeed 320. This program clearly shows how each subclass can build upon and extend the functionality of its parent class. Hierarchical inheritance occurs when multiple child classes inherit from the same parent class. All the child classes share the features of the common parent, but each child class can also have its own additional features. In this type of inheritance, there is only one parent class but multiple child classes inheriting from the same parent. Hierarchical inheritance helps in sharing common behavior across different subclasses. It promotes code reuse and organized structure by centralizing common features in a single parent class. Let us look at an example to understand hierarchical inheritance. This program demonstrates hierarchical inheritance in Python where 2 child classes inherit from the same parent class. The base class vehicle has a constructor in it that initializes the fuel attribute. It also defines a method fuel type that prints the type of fuel used by the vehicle. The bus class inherits from vehicle, so it can access all attributes and methods of vehicle. In the bus constructor, super.init with fuel as a parameter is used to call the parent class constructor to initialize the fuel type. The bus class also defines an additional attribute capacity to store the number of passengers it can carry. The method showCapacity prints the bus passenger capacity. Similarly, scooter class also inherits from vehicle. Its constructor also uses super.init with fuel as a parameter to initialize the fuel type using the parent class. Scooter defines its own attribute weight and a method showWeight to display it. An object B of the bus class is created with fuel type diesel and capacity 50. An object S of the scooter class is created with fuel type petrol and weight 120. The method b.fuelType calls the parent class method and prints fuel type as diesel. The method b.showCapacity prints bus capacity as 50 passengers. The method s.fuelType also calls the parent class method and prints fuel type as petrol. Finally, s.showWeight prints the scooter weight as 120. This clearly shows how both bus and scooter inherit common features from the vehicle class while also having their own unique attributes and behaviors. Hybrid inheritance is a combination of two or more types of inheritance like single, multiple, multi-level or hierarchical in a single program. It allows developers to build complex class relationships while reusing the code efficiently. Hybrid inheritance brings together different inheritance styles such as one class inheriting from multiple classes, a class being a part of a multi-level chain, and multiple classes sharing a common parent, all in one structure. Let us look at an example to understand hybrid inheritance. This program demonstrates hybrid inheritance in Python where multiple types of inheritance, single, multiple and multi-level, are combined in one structure. The base class vehicle has a constructor that initializes the category of the vehicle and a method showCategory to display it. Another class electric is defined separately which represents electric features of a vehicle. It has its own constructor to initialize battery range and a method showRange to display it. The bike class inherits from vehicle, making this a case of single inheritance. It also adds a new attribute brand and defines a method showBrand to display the brand. The electric bike class inherits from both bike and electric, which makes it an example of multiple inheritance. In the constructor of electric bike, the bike.init method and electric.init method are called to initialize all inherited attributes. The electric bike class also defines a method showInfo that calls methods from all parent classes, showCategory, showBrand and showRange. An object EB is created from the electric bike class with the category two-wheeler, brand Hero Electric and battery range 80. The eb.showInfo method prints all details of the electric bike and prints a title message electric bike details. The showCategory is called to display category two-wheeler inherited from the vehicle class. ShowBrand is called to print bike brand which is Hero Electric inherited from the bike class. Finally, showRange is called to print battery range which is 80 inherited from electric. This program shows how a class can inherit functionality from multiple classes that are themselves in different inheritance relationships. It uses both super and direct parent class calls to initialize base class attributes. Let's take a moment to assess your understanding with a couple of quick multiple choice questions. This will help you review and reinforce what we have covered in this tutorial. Here is the first question. Which method is used to initialize instance variables in a class? Take a moment to think about your answer. The correct answer is option B. Here is the next question. What is the purpose of a static method in Python? Take a moment to think about your answer. The correct answer is option C, to perform tasks unrelated to instance or class data. Here is the next question. What type of inheritance is demonstrated when a class inherits from two or more classes? Take a moment to think about your answer. The correct answer is option D, multiple inheritance. Here is the next question. Which of the following is an example of hierarchical inheritance? Take a moment to think about your answer. The correct answer is option A, one parent class with multiple child classes. If you got all the answers right, good job. If not, don't worry. You can revisit the explanation in the video. The lecture video offered a comprehensive introduction to object-oriented programming in Python. Through a wide range of practical and relatable examples, the lecture video explains how to create user-defined classes, instantiate objects from those classes, and utilize methods and attributes to perform operations. In addition to the basics of classes and objects, the video introduced one of the most essential and powerful features of object-oriented programming, inheritance. It provided a clear explanation of how inheritance allows one class to acquire the properties and behaviors of another class, promoting code reuse and making complex programs easier to manage and extend. The video explored the different types of inheritance supported in Python, each illustrated with real-life examples to make the concepts more accessible and meaningful. The video demonstrated inheritances like single inheritance, multiple inheritance, multi-level inheritance, and hierarchical inheritance along with hybrid inheritance. Overall, this lecture served as a comprehensive guide to understand and implement object-oriented programming through classes and objects and inheritances in Python, setting a strong base for more advanced programming topics and applications. Thank you for watching this video.